right, welcome back. So in this video, I'm just going to do problem 53 from chapter 2. And of course, here we have this firm that sends out these technicians to regular and new customers. So I'm just going to let R, stand in for my regular customers, and N, of course, for my new customers. And what I want to do here is HTS would like to determine how to allocate technician time between regular customers and new customers so that the total number of customers contacted during the 2-week period will be maximized, right? Well, if R stands for regular customers and N stands for new customers, then all I'm trying to do is maximize R plus N, right? That will tell me how many new customers I have reached. Okay, so then subject 2, I got a few constraints. I have my profit constraint. I need to generate at least $800 in revenue, and the regular customers generate 25, so 25 times R, plus 8 are the new customers, and that has to be greater than or equal to 800. And then I have my time constraint. I've got 80 hours of technician time over the next 2 weeks. And for a regular customer, it takes 50 minutes to meet with them. So I have 50 divided by 60, right? Because everything's in, I need to put it into per hour. That's regular. And then it just takes a full hour to meet with the new customers. And that's got to be less than or equal to 80 hours, right? Yeah, 80 hours. Okay, and then I do have one more constraint. So it says that to ensure that new customer contacts are being maintained, the technician time spent on new customer contacts must be at least 60% of the time spent on regular. Okay, so in other words, new customer contacts, so new customers must be greater than or equal to 0.6 of regulars, right? So I have N minus 0.6 R greater than or equal to 0. So that is going to be my last constraint. So I'm going to, run out of room here. So I'll put that in. So I have a negative 0.6 R plus N greater than, I don't know what I'm doing, greater than or equal doesn't like the negative out here. So I'll do it this way. There you go. So negative 0.6 R plus N has to be greater than or equal to 0. Okay. So once again, I apologize. This was a pretty easy formula, though. So I probably should hit the eraser. Let me just get rid of that. Okay, so now I want to set everything up. So R, come on, N, parameters, choice variables, objective function, okay, so here's just 1 and 1, right? 1R plus 1N. Choice variables, I'll put a placeholder of 1 and 1 in there. Objective function, which I'm sure you all know by now, is just our parameters and our choice variables. Okay, and then I have the 3 constraints. So constraint 1. Okay, let me try to make these a little bit smaller. Okay, so 25, of course, 8. And then here, 50 divided by 60. So let me just, there. Well, I don't want to go that big, jeez. But that's 0.83. Oh, we'll call it 0.8. 1, negative 0.61. And then I have greater than or equal to, less than or equal to, greater than or equal to, And something is wrong over here. This is the profit. That's 800, sorry. Okay, so now I have 880 and 0. All right, back in business. Okay, now we can see everything. Well, we could. All right, so now I got to put in my constraints. Okay, so my choice variables, parameters from the constraints, hit OK, anchor, copy, voila, I'm ready to go. So, data solver, okay, I want to maximize that function by changing these two cells, subject to this number being greater than or equal to this number being less than or equal to this number, and then this number being greater than or equal to that number. I check the box for my non-negativity constraint, simplex LP, solve, voila. So, there you go. So I should, what this is telling me is I'm going to meet with 55 regular customers, 33, what do they call these, new customers, for a total of 89. And yes, you could probably round up, right? Say 56, 34, 90, but you get the idea. So there you go. That's the solution to 53. We have one more to do, and then we are done for the week.